We're going to begin 6.6, which is solving quadratics by square roots. A lot of what you're going to see today is not new. It's more of a sense of what we're putting together. So let's go ahead and take these notes. Go ahead and pause the video so you can take the notes. From these notes, you can see that this method of solving these quadratics by square roots is perfect for when there's no bx term. So when we recognize that, hey, which kind of just has a square and then a constant, let's use square roots. Because essentially what you're going to be doing is after learning all of these methods, you have to figure out what works best or quickest for those specific types of problems. You're going to isolate the x squared, and then you're going to take the square root. You're going to undo that exponent. So let's go ahead and do problem number 1. I'm going to draw my line down the equation. And I am going to add 16 onto both sides so that I am left with 16 equals x squared. In order to isolate the variable, I need to take the square root of it, right? I'm trying to think what number times itself will give me x. In this case, it is a 4, but what you're actually going to get is a positive negative 4. Because a negative 4 times a negative 4 gives me a 16, and a positive 4 times a positive 4 also gives me 16. So both of those answers work, so your final answer is a positive negative 4. Now you can write this as a negative 4 comma 4, that's fine too, right? You could also put the abbreviation with a positive negative. Go ahead and try number 2 before we move on, and I'm going to show you the answer, so go ahead and pause the video here. Now that you solved number 2, I'm going to show you the answer. So you get a positive negative 10. Let's go ahead and try number 4 together. So number 4, as before, we're going to draw a line. I'm going to subtract 25 from both sides. And so I'm going to get an x squared equals a negative 25. I'm going to take the square root, except, hold on, I know 5 times 5 gives me 25. I know negative 5 times a negative 5 equals 25. How do I get a negative 25? This is where we start to get into algebra 2 concepts. In this case, you get a no real solution. There's not going to be a real solution for this. Yes, that means there is an imaginary solution. Essentially, what we're looking at is we have x squared equals the square root of negative 25. That cancels out. So you get x equals, this square root of a negative is taken care of with I, right? I stands for the imaginary number. We're getting into complex numbers, and we're still left with square root of 25. Square root of 25 is 5, so we get a positive negative 5i. Again, this would be your final answer, but right now at our level, we're going to stick to the no solution. If you want to try and practice with these complex numbers, that is up to you. So next to this, we're going to make sure that we write that it is not possible to take the square root of a negative number and get a real solution. So our answer is going to be no solution. So when you're taking square roots of things, you're going to want to be careful as you solve them. Go ahead and pause the video so you can take these notes. But let's move on in our practice. We're going to go a couple pages over. And let's do number 2 here. So I draw my line down the middle, down our equal sign. We're going to add 3. So I get x squared equals 3. Let's take the square root of that. Except 3 is not a perfect square. I can't take the square root of that. So guess what? Your answer is just positive negative square root of 3. What you want to make sure you do is that you get to the simplest radical form. We've done simplifying radicals before, and if not, you might need a refresher. Right? So zeros can be irrational. The square root of 3 is an irrational number. You can get the positive version of that, you can get the negative version of that. Right? We're solving all these equations as we've always been, but we're going to want to make sure that we put our answers in simplest radical form. We are going to practice one where, you know what, I could probably simplify this radical. So we're going to do number 3 to help us practice with that concept. Oops. We're going to go and add 8 to both sides. So I get x squared equals 8. I take the square root of it, So I get x equals square root of 8. But this is not done. Because if I list the factors of 8, we get 1 and 8, we get 2 and 4. And what I notice is that there's a perfect square in this set. So what if I split this up? I get the square root of 4 times 2, which I know is the same thing as the square root of 4 times the square root of 2. Again, all we've done is so far just split it up. That's it. I can take the square root of 4, that's a positive negative 2, and I'm left with times square root of 2, except you don't really need that multiplication symbol in between. You can kind of just put this together. So our final answer is a positive negative 2 root 2. This is a simplified form of that. I want you to try problem number 4 right next to it. So go ahead and pause the video as you try problem number 4 and these problems are left on your screen. Let's see if you got the correct answer for problem number 4. You should have gotten a positive negative 4 root 3. What you end up splitting 48 into is 16 and 3. 16 times 3 gives me 48. I could also take the square root of 16 and get a positive negative 4, but I can't take the square root of 3, so that square root of 3 stays there. There is one more type of problem that we're going to, or two more types of problem that we're going to look at because they do get a little tricky, right? They get longer. So let's go a couple more pages over. And we're going to focus on problem number 1 and problem number 2. Let's do problem number 1 first. We're going to still follow SADMAP. We want to get rid of what's on the outside of the parentheses first. So in this case, that means dividing by 6. So I get x minus 4 squared equals 7. Well, I can't go into the parentheses because I have that exponent. So let's take the square root of it. That gets rid of that. I'm left with x minus 4 equals positive negative square root of 7. I can't simplify that. So I'm going to have to leave it as a square root, and I can't even simplify the radical. So it stays as is. And then I still have to isolate my variable, so I'm going to add 4. This is going to look a little different than what we're used to, but it's going to be 4 plus or minus square root of 7. We're not actually solving for what square root of 7 is, as it's an irrational number. So here is our final answer. Don't worry, I'm not going to ask you to plot this right now, right? These are decimals that are not going to be possible for you to plot. Just with this, you would need a graphing calculator. But let's try number 2, because this is where it's like, whoa, hold on, I can do the math here. So, as we just did, problem number 1, we're going to do the same thing. We're going to get rid of what's on the outside and divide by 2. I'm left with an x minus 2 squared equals 9. I'm going to take the square root, and I actually can take the square root of 9. I get a positive negative 3. So I'm going to have to split this up because one equation is telling me it's set equal to 3. The other one is telling me it's set equal to negative 3, and I'm going to solve those individually. I'm going to show you what those answers look like, just so that you can take the notes. Some of you might even want to solve it this way. Just make sure you keep track of what number you've already tackled in the calculation. And then here's a set of notes to go along with it. When you are done, go ahead and try problem number 9 at the bottom. Pause the video. And now that you've tried problem number 9, let's see what our answer is. So we added 20 first. Then we had to divide by the 11, get rid of the square root. I can't simplify square root of 11. So then I multiply by 2, which goes in front, and then I add 7. So I get a 7 plus or minus 2 root 11. Again, these are tricky, so you're going to need tons of practice.